All right, welcome back. Today we are going to learn about powers and exponents. And some of this you may already have been exposed to, but it's always good to come back and take a look at how to use different techniques and different skills in algebra. So, two things you need to know about powers and exponents. You need to know what the base is and what the exponent is and what those mean. Okay, so the base is just a repeated number that's being multiplied together. So 2 in this example is a factor, or the number that's being multiplied by itself. The exponent tells us how many times that number is multiplied by itself. Okay, so 2 times 2 times 2 times 2 can be written as 2 to the fourth power. Okay, we also call that a power. That exponent is also called a power. So in these two examples, they want us to go ahead and write each expression using exponents. You do not have to find what it's equal to. We're not looking for a final answer. We're just looking to write these with exponents, okay? So the first thing you can do is go ahead and group them together. The associative property allows us to group numbers, right, to associate numbers together. And then we can write each of these with their own exponent. Well, 1/2 is occurring 3 times, and the factor 3 is occurring 4 times. So we can write that as 1/2 to the third power and 3 to the fourth power. Now, the parentheses are important with the fraction because the third power means both the numerator and the denominator are multiplied to the third power. Okay, so the parentheses are absolutely necessary when you have a fraction. Okay, it's not necessary when you have a whole number, but when you have a fraction, you have to have the parentheses. So make sure you understand that. All right, our next example just has letters. We have A times B times B times A times B. So again, you're going to want to organize those first, put them together next to the letters that are similar. And so rearranging those, remember that's the commutative property. We can switch around the order of how numbers are multiplied. That's the commutative property. Then we're going to use our associative property to group them together. And now we can see that A is multiplied by itself twice and B is multiplied by itself 3 times. No parentheses necessary because we didn't have any fractions. All right, here's a couple to try. Let's go ahead and just work on these together. So the very first thing we're going to do is to reorder them, right? So we're going to have 2/3. How many times is that going to happen? 1, 2, 3, 4 times. So we're going to have the number 2/3 times itself 4 times. I'm just going to go right to the answer here. I think these are easy enough that you'll be able to see what's going on. And then we're going to have 7 multiplied by itself twice. And then just put a multiplication sign in between there. So let's just double check our answer. So we have 2/3 to the fourth power times 7 squared. Look at letter B. We have how many m's and how many n's? We have some m's and then we have some n's. And all we need to do is count them up. There's 1, 2, 3 m's. So the thing to make sure you understand, it's not 3 times m, it's m times m times m. It's different, right? And then we also have 1, 2, 3 n's, n to the third. All right? And lastly, letter C, we have 3 times A times B times 2 times 3 times A. So we got a whole lot of stuff going on here. So this one I am going to reorder. I'm going to put the 2 first and then the 2 3's. So I took care of that one, that one, that one. And then it looks like I have 2 A's, A times, took care of that one, and now I have a B left, right? So that's how I would rewrite those in order. So in order to go ahead and figure out my answer, this is going to be 2 times 3 squared times A squared times B. Okay, now they may multiply out the number part here. I'm not sure how our answer is going to look. If they do that, 3 squared is 9, so this is really 2 times 9, which is 18, and then we still have A squared B. So I suspect that's what they have for the answer, but let's go ahead and take a look. No, they didn't. You can leave it in the other form, so didn't need to do that, so I'll go back and erase that. Don't put that in there. 2 times 3 squared, A squared B. All right, so exponents can be positive or negative. This is an example, or I guess a rule that's going to show you how you can go ahead and get negative exponents. If you look at this table, the standard form of the number 1000, if we want to write it in exponential form, that's really 10 to the third power. It's 10 times 10 times 10. Moving down the table to get from 1000 to 100, we're dividing by 10. Okay, so that's really 10 times 10, or 10 to the second power. 10 by itself is really 10 to the first power. Okay, and so that's 10 to the first. If we divide 10 by itself, we get 1. So that's really 10 to the 0 power. And look what's happening to your exponents. It's going 3, 2, 1, 0, and then it goes negative. So now we have a fraction. 1 over 10 is 10 to the minus 1, and 1 over 100 is 10 to the minus 2. So we have kind of a pattern going on here, and the pattern that we see is this. Any non-zero, now this is an important part right here, non-zero, okay? It can't be 0. 0 to the 0 power is undefined. So any other number that is to the 0 power is equal to 1. So 5 to the 0 is 1, 10 to the 0 is 1. Anything at all. You could have some really complex number or algebraic expression, and if you put it to the 0 power, it's going to equal 1. Any number to the 0 power is equal to 1 as long as that number is not 0. The other thing that's interesting here is any non-zero number to the negative n power. So any number, x is just a negative, or excuse me, x is just a number, and if it has a negative exponent, that's just equal to 1 over whatever that number is to its positive exponent, where x cannot be 0 because we can't divide by 0. So in numbers, if you have 7 to the minus 3 power, that's really equal to 1 over 7 to the positive 3 power. So the way to get rid of a negative exponent, you just use a fraction and put it in the denominator. So, and you can see from our table up here, 10 to the minus 2 is the same as 1 over 10 to the positive 2. So let's see how we would use that. Our directions are to evaluate what's in the parentheses. So we have 2/3 to the 4th power. Well, we know that that means 2 times 2 times 2 times 2 over 3 times 3 times 3 times 3. It's 2/3 times itself 4 times, right? So whenever we see evaluate, we are going to get a final answer. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, okay? 3 times 3 is 9, 9 times 3 is 27, 27 times 3 is 81, so we should get 16 over 81. You also you should have on your calculator a button somewhere that is probably like a Y to the X button on your calculator. That will help you do some of these exponential evaluation problems. So let's take a look at a negative exponent. 4 to the minus 3, what does that equal to? Well, that's equal to 1 over 4 to the positive 3, right? That's what our rule told us. But what is 4 to the third equal to? Well, 4 to the third is really 4 times 4 times 4, right? So that's 16 times 4, which is 64. But remember, it's 1 over that, so it's 1 over 64. All right, here's another one. Evaluate a squared times b to the 4th if a is 3 and b is 5. Well, now we're going to substitute in 3 for a and 5 for b. So what is 3 squared times 5 to the 4th? Well, 3 squared is 9. 5 to the 4th, we're going to write as 5 times 5 times 5 times 5. So it's 9 times 625. And on your calculator, you should get 5,625. All right, here's a couple to try on your own. Go ahead and pause the video, and I'll help you with these when you get back. All right, hope you took a chance at those. See what you came up with. 1/15, that's 1 over 15 times 1 over 15 times 1 over 15, right? So what we're going to do there, multiply your numerators and you get 1. 1 times 1 times 1 is 1. What is 15 times 15 times 15? Let me get my calculator going here. And, whoops. It looks like that's 3375. Okay. How about 5 to the minus 4th? That one is 1 over 5 to the positive fourth. So that's 1 over 5 times 5 times 5 times 5. So 5 to the fourth power is 625. Okay? And letter F, we want to know what c to the third d squared. Well, c is -4. We're going to raise that to the third power. And d, we're going to raise that to the second power, and d is equal to 9, right? What is -4 to the third power? That's -4 times -4 times -4. 9 squared is 9 times 9. Well, we know that's an 81, right? Negative times a negative times a negative. I think we've talked about this before. If you have a negative number and the exponent is odd, then your number will be negative. But if you have an exponent, excuse me, if you have a negative number and your exponent is positive or is even, then it will be positive. So 4 times 4 is 16 times 4 is 64. And now we need to multiply 64 times 81. And that gives us 5,184. And it's negative because we have a negative times a positive. So let's just double check our answers real quick. 1 over 3375, 1 over 625, and -5184. Not too bad. Here are 8 problems for you to try on your own and bring to class when I see you again next time. Hopefully you won't have any trouble with these. We'll see you next time.